viewers and dear students, today we have a new topic, that is we have already discussed the previous topic with replacement case. Today we will discuss about the problem of without replacement case. We start from the without replacement case, solution of numerical problems. Draw all possible samples drawn without replacement from the samples n is equal to 3 and the population on 2, 4, 6, 8, 8, 10. 2, 4, 6, 8, 10. There are, for example, there are 5 populations, 2, 4, 6. Draw all possible samples are drawn without replacement from the samples n is equal to 3 and the population are 2, 4, 6, 8, 8, 2, 4, 8, 8, 2, 4, 8, 8 and 10 are required, and also we verified the property of the mean of the population mean, that is also called expected value of x bar is equal to mean of x bar is equal to mean, and population standard deviations variance of x bar sigma standard deviation of mean is equal to sigma divided by n minus n divided by n minus 1 without replacement case, that is called n minus n minus 1 square root. This is FPC, finite population correction is required. First of all, we draw all possible samples without replacement case. So here sample size is denoted by small n, it is already given n, and population size are also given, that it is denoted by 5, and it is also given 2, 4, 8, 8 and 10. These are the populations. Now we are all possible samples are required without replacement case. We use the without replacement case. We use without replacement case all possible samples are n combination n. That is the formula without replacement case we are using. If we expand this one, and here's n is equal to 5 and c is n is equal to 3. So according to the combination formula, we can use that one. N combination r is equal to n factorial r factorial n minus r factorial. According to this rules, if we expand this one, 5 combination 3 is equal to 5 factorial and r is equal to 3, that is selected from the sample of size 3 factorial and 5 minus 3 factorial. Now expand this one, 5, 4 and 3 factorial, 3 factorial and 5 minus 3, 2 factorial, 3 factorial cancelled, 2 factorial is equal to 2. So that is cancelled to each other. So we get here 10 samples. It means that here we drawn all possible samples are required. Now the case is without replacement. So it means that according to the definition of without replacement, so if we once drawn the sample size, then we cannot return to the original one. So it means that we cannot return to the back side. So we are going to the forward side. So for example, if we are starting from 2, so we will proceed. There are 3 selections required. Sample 2, 4, 2, 4, 8, 2, 4, 8, 2, 4, 10. The first one we take 2, 2, 4, 8, 2, 4, 8, 2, 4, 10. Means that so that one is now finished. Now we are going to the 2, 4 and now 2, 4, 2, 8, 8. Now 2, 8, 8, 2, 8, 10. So this is also finished. So 2, 8, 10. 2, 8, 8, 2, 8, 10, 2, 8, 10. Once again, in the last one, we get 2, 8, 10. Now the process of 2 is finished. Now we start from here from 2, 4, 8, 8. 4, 8, 8. 4, 8, 10. 4, 8, 10. 4, 8, 8, 4, 8, 10, 4, 8, 10. Once again, we get 4, 8, 10. Now, here the last one we are required 4, 8, 8, 8, 10. The other there is not possible the other solution of this one if we draw 3 samples at a time. So now we count this one, we get 10 sample or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Means that our answer is correct. Now we are proceeding to their samples means because here according to the first property the mean of mean is also required. So we draw here x bar. X bar is equal to summation x divided by n. So we can calculate this one means that 2 plus 4 plus 8 divided by sample size is 3. So we get here 10, 10 plus 4, 14, 14 divided by 3, we get the answer 4.67. 4.67. Similarly, 2, 4, 8, 10. Once again, we get 4.67. And here is 2, 4 plus 10. We get 14, 16. 16, if we get 5.33. 5.33. Here is 10. We get here 6. 2 plus 8, 10. 8 plus 18. 18 divided by 3, we get 6. Similarly, if we divide by this one, 20, 6.67. And here once again 6.67. Similarly, here is 20. 16, 20. 20 divided 6.67. Once again, 3 times we get 6.67 is coming 4, 8, 8, 16, 20. And here 4, 8, 8, 18, 22. 22, 7.33. 7.33. Similarly, and here 7.33. 18, 26, 26, we get 8.64. Now we are needed here the mean of the sample mean. So here sampling distribution or probability distribution. Sampling or probability distribution of x bar. So here x bar, we draw another construction. First of all, we check the smallest value here is 4.67 and further is 5.3 and 6.67 and 7.33 and 8.64. Now here frequency is required. Frequency means the number of repeated value, how much repeated, how many times this is repeated. 4.67, 4.67 is 2 times is repeated. It means the number of frequency is 2. Similarly, here is 5.1 is 1.1 times repeated, 6 is 1 time repeated, and 6.6 is 7 is 3 times repeated. Similarly, here is 1 time and also 1 time. Now, f of x bar means probability. F of x bar means probability. Probability means the number of favorable outcome divided the total number of outcome. Favorable outcome is here 2. 2 divided by total number of outcome is 10. We have already calculated. Here is 1 divided by 10, 1 divided by 10, and 3 divided by 10, 1 divided by 10, and 1 divided by 10. So now look here, this must be 10 divided by 10. So there is probability must be equal to 1 here. 2 plus 1, 3, 4, 4, 4 plus 3, 7, 8, 9. It means that here is some mistake is coming here. The probability 7.3 is 2 times. So here will be 2 times. Now the answer is correct. 10 divided by 10. So the probability must be same. Otherwise, if from your result is coming less than 1 or greater than, so it means that your answer is incorrect. So must be checked. Now x bar and f of x bar is required from the sampling distribution of this one. So this column and this column multiplies to each other. So we get the answer 4 multiplied by 6, 7 multiplied by 2. We get the answer 9.34. 9.34 divided by 10. Similarly, 5.33 multiplied by 10 and 6 multiplied by 1, 6 multiplied by 10. 6.67 multiplied by, we get 20.01, 20.01 divided by 10. Similarly, 7.33 we get 14.66 divided by 10 and 8.64 divided by 10. Now here we are required some of the values, some this will be cancelled, this will be 10, and here we add this term, so this is equal to 64 if we add 64 divided by 10. Now another column is required for the standard deviation or variance, so x bar whole square f of x bar. Now this column x square is required, means that we double this value and multiply by the frequency of this column f of x bar. 4.67 if we multiply double this and multiply by 43.618 divided by 10. Similarly, 5.33 if we double this number and multiply by 1, so we will get the answer 22.410. Here is 36, 36 divided by 10. Similarly, 6.67, if we double this number, we get the answer 133. 7.467 divided by 10. Similarly, 7.33, if we double and multiply by 2, we get the answer 107.455 divided by 10. Similarly, 8.64, if we double this number according to this formula, so 75.16 divided by 10. Now we add sum of this column is total of these columns, and replace of sigma we sum we can write also sigma or total, both are same. 422 422.12. If we sum this number, so we get 422.12 divided by 10. This is the sampling probability distribution. Now we want to prove the results. The result is, first we prove that mu x bar, that is also called expected value of x bar, is equal to sum of x bar f of x bar. Now we have already done this column x bar f of x bar, we get the result 64 divided by 10, so the result is 6.4. Now we want to check this result with the result of mean. This is means population mean. This is called population mean. Population mean summation x divided by capital N. If we are using sample, then we are divided by small sample size. Now x means here the value of x, we have already done the population 2, 4, 8, 8 and 10. These are the population, and also sum of x square will be required, and the population variance x square will be required. So we 4, 16, 64, 64 and 100 from this tables. So now we add this column, so we get the answer. What is the result of this column? 32, and here 248. No further calculation is required, and summation x divided by n we get 32 divided by total n is equal to 5. 1, 2, 3, 4, 5. So divided by 5 we get 6.4. So the above result both are same. That means that expected the mean of the sample mean, that is called the mean of the sample mean. So it is expected value of x bar is equal to mean is 6.4. Both results are same. Now we want to property of the variance. Variance property we have sigma x bar is equal to summation x bar whole square f of x bar minus summation x bar minus f of x bar whole square. This is the property of square root, because this is also square root we have done here. So if we substitute the value of summation x square, this is the result of x square. Sigma x bar is equal to 422.12 divided by 10 minus mean we have already done in the first step 6.4 whole square root. If we calculate this results, so the result will be equal to 1.0 0.08 square root. If we take the square root, so we get 1.039. This is the value of sigma x bar. Now we are required here population mean and population standard deviation is also required. We want to verify these results by population formula. So sigma is equal to summation x bar divided by n minus summation x divided by n whole square root. We have already done summation x square, we get 248 divided by 5 minus summation x divided by n, we have already done 6.4 whole square. If we calculate this result, so the result will be equal to 2.394. This is the value of sigma. Now we want to verify the result. Sigma, we want to verify that is this result is sigma divided by n to n minus n divided by n minus 1. We have already, this is called finite population correction. So we are using this vector in the without replacement case. Now we calculate this result. This result is also here, square root is also involved here. We substitute the result sigma we have get the answer 2.394 divided by n is 3 square root and n is 5 minus 3 and 3 minus 1 square root. If we calculate this results, so the result we will get here 1.20. So this is the result of sigma x bar. Sigma x bar, we have already results. It means that both results are same. So the given result, the given statement are, so if we round this one, so the result will be approximately 1.20. Both results are same. The above property are also same. Thank you very much for watching. Please subscribe my channel. Once again, appreciate you in advance.